How's it going, everyone? My name is Alan Segala. Hopefully, you've all had a fantastic first week at your in your master's program. Today, we're going to go ahead and talk about ATP pathways. So let's go ahead and get right into it. So, what is an ATP? An ATP is called an adenosine triphosphate, which is the source and energy acts as protein for cells in the human body. ATP is made out of aden- adenine, ribose, and three phosphate groups. Um, ATP is what makes people's energy. So if you think about it, to kind of relate, think about a vehicle, a car. What makes a vehicle run? Obviously, have it's oil, it's gas. Um, a lot of it is the source of energy for that car to run. So without that source of energy, it is very likely that that car and vehicle will not run at all. Um, so ATP is really the energy source for for a human, because without our energy source, we wouldn't be able to get up out of bed, um, do what we got to do for the day, for the week, go to work, especially go and do physical activity, especially physical activity because ATP is a huge must on getting physical activity done. We're gonna go ahead and talk about the different pathways of ATP. We're gonna go ahead and start with the glucose diagram, other known as through glycolysis. So during glycolysis, glucose ultimately breaks down into pyruvate and energy. Um, it is uh, it is initially broken down into pyruvate, which would be followed by the Krebs cycle, um, which further oxidizes the pyruvate. Um, After that, it finally oxidates phosphorylation, where the majority of ATP is generated, um, going through the electron transport chain. If you look closely to the diagram, you'll see that glucose plus 2-NAD, 2-ADP, and 2-PI creates the 2-pyruvate. The PI stands for inorganic phosphate. Um, the NAD is the nicotinamide adenine um, dinucleotide, um, and then ADP is adenosine diphosphate. Um, So those creates the two pyruvates, which leads to add with the two NADH with two hydrogens plus the two ATP and two waters. Um, so the hydroxyl groups allow for the phosphorylation. So next we're going to go ahead and talk about how fat is broken down to produce ATP. So taking a look at the fat diagram, um, we can see that fat is broken down into fatty acids, which are then converted to acetyl-CoA through beta oxidation. Then with the acetyl-CoA enters the citric acid cycle to produce electrons that are used by the electron transport chain to generate ATP. So taking a look at the next slide, now knowing how each glucose and fat create ATP in their own ways, um, we can take a look at how much ATP is produced by each of them. So with glucose, it is approximately 36 to 38 ATP that is produced in comparison with the with fat um, that can average around 120 ATP. So taking a look at how these pathways interact across exercise, intensity, and duration. Um, ATP is limited and regulates energy metabolism. So the more you work out, the more intense the workout is. Um, the the increase in energy that is going to be required. So that energy is broken down from the stored energy to resynthesize that ATP because you're already using as much ATP that is made for the workout. So the body has to go for the stored energy and resynthesize the ATP. So depending on the intensity, it determines how fast the system increases the energy transfer. So obviously, more intense, the faster the body is gonna try to make more energy for you, so you can keep up. So you're not out of oxygen, you're not out of the energy. Um, this is a way for the body to keep you going to finish off your workout. So obviously we know what anaerobic and aerobic physical activities are. Um, it is said that anaerobic physical activity generates a rapid increase in glycogen breakdown um, because anaerobic doesn't have to deal with oxygen. So you're thinking about like doing a sprint, powerlifting, anything that doesn't have to deal with heavy breathing or much oxygen. Um, you're going to be looking at more of the glycogen breakdown. So more intense activity results in hydrogen to strip away from the carbohydrate. Hydrogen flows to pyruvate, which makes lactate and flows through the blood and muscles being worked. So obviously, um, a lot of workouts, higher intensity, you're going to be getting a lot of that lactate acid coming through your body, going through your blood, through your muscles. Um, it is what keeps your muscles warm, but it's what makes you feel sore at the end of the workout. It is a response from the body to pretty much get yourself rested, so you don't overexert yourself the next couple of days. With aerobic physical activity, the fatty acids enter the aerobic metabolism, and the fat is stored as the triglyceride. So primary factors that limit ATP production. Um, Obviously, you need to eat. Like going back to previous slide, um, going back to the car simile or metaphor. Um, Without the car's gas, oil, it's gonna have a hard time running. It's the same thing with as a human. Without your food, without your energy, you're not gonna get far. You're not gonna be able to get out of bed. You're not gonna be able to go and do what you gotta do. So obviously, food is a um, big source of energy that can limit ATP. Oxygen as well. Um, you obviously have to have oxygen to make ATP. Because if you're not breathing, if you don't have access to oxygen, uh, ATP is going to be limited um, whenever. So applying to the real world, physical activity, obviously, you need your energy um, to to keep you going. If you're going out for a run, a walk, whatever it is, you're obviously gonna need it. You're obviously gonna need your energy to keep you going to finish and cross that finishing line. It is our main energy currency. It's what keeps us running. It's what keeps us going. Um, Whether that is walking, talking, whatever is needed physically done, ATP is happening and producing. And these are my references. Thank you guys for going through the video. Um, and thank you for your time. Hopefully, you guys have a great second week and uh, enjoy the week. You guys have a good one. Bye bye.